So back in the day, this has to do with this unit. So back in the day, Carl Friedrich Gauss, back when he was literally in grade school, he was in class one day and his math teacher was being super lazy and didn't want to teach math that day. And so he gave them a tedious assignment. He said to the students that were these wee little lassie and laddies running around, he said to them, I want you to sum up the numbers from 1 to 100. And he thought that's going to take them all hour because they're little kids, they're going to have to add it up and whatnot. So he sets them free, and within a matter of a few minutes, Carl Friedrich Gauss walks up with the answer. Says, teacher, the answer is 5,050. And the teacher's like, he had summed up the numbers way before. He's like, that's the correct answer, but how did you get that? You must have cheated. And Friedrich Gauss said, I didn't cheat. I just noticed something interesting. Wow. Anyone notice anything? Yes. Yes, you're on the right. You're absolutely doing the exact same thing, roughly what Gauss did. So, notice a couple things here. You're going about it the same way Gauss did. Notice something really interesting. What's 1 plus 100? 101. Now, okay, so that pair is 101. What about 2 and 99? What does that sum up to be? 101. Oh, interesting. So that's another pair of 101. 3 and 98 sums up to be, okay, how many pairs of 101 are we going to have in here? 50 pairs. That's literally what he did. He was back in grade school. He said there's 50 pairs of 101. 50 times 101 is 5,050. And so his teacher's like, whoa, you're smart. And then that's where the formula was developed. N over 2 times A sub 1 times A sub n. The sum formula for an arithmetic series. Really cool story. So anyways, pretty smart because, I mean, I probably wouldn't have recognized that at my older age, and he was just a young lassie. Some people are just laddies. Young laddie. He wasn't a girl. All right. Okay. So we're just going to go over a few things to help you with the test. I do. You are not going to have, so you should have your formula worksheet out. Everybody get that out real quick. Okay, so everybody listen. The first thing I do when I sit down to the test is from memory, write down all the things that I'm about to write down with you. You've already have most of it written down on your formulas worksheet, but I just want to give you an example of what you should see. If you're doing it from memory and that's the first thing you write down on the test, you're being a smart test taker. That's not cheating. You're doing it all from memory and whatnot. So the first thing I do when I sit down for this test is write out some formulas so that in the middle of the test I don't go mind blank because I'm thinking about so much things. I can refer back to it. So I'd say to myself, okay, there's arithmetic and geometric. Sequences are just a sequence of numbers. To find any term in a sequence, there's two formulas, recursive and explicit. Recursive, and I'm just going to abbreviate, explicit. Recursive formulas are a formula that you can find any term in a sequence given the previous term. So A sub n is equal to A sub n minus 1, the previous term. It's arithmetic, so we'll be adding our difference, adding d, plus d. Plus the common difference. An explicit formula is a formula you're going to be using mostly on the test. And for an arithmetic sequence, the explicit formula allows us to find any term in a sequence, and it's a sub 1 plus n minus 1 times by the common difference. That's a plus sign. All right, everybody? That's the first thing I write down on the test. Then I say, the sum of an arithmetic series, I can only find the sum for arithmetic if it's finite. And the formula is S is equal to n over 2, sorry, you can write it two different ways, so that's why. N over 2 times A sub 1 plus A sub n. That's Gauss's formula, that he recognized the pattern happening. All right, so the S of this many terms. All right, geometric. I say, okay, geometric has recursive and explicit formulas for sequences. And explicit, a recursive formula, once again, is written in terms of the previous term. So A sub n minus 1 times by the common difference, not times by the common ratio, sorry. times by the common ratio. And an explicit formula would be a sub n is equal to a sub 1 times by the ratio raised to the n minus 1. You'll be using those formulas a ton, and so it's nice to have them. Then I say to myself, sum of a geometric series, we can find it for finite. So for finite, if it's geometric, you use the formula S of n is equal to a sub 1 times 1 minus r to the n divided by 1 minus r. If it's infinite, there are times when you can find the sum. If your ratio is less than 1, if it's getting smaller and smaller, but it's infinite, it's going to approach 0, so you'll converge to a sum. So it converges, and it converges to the sum of a sub 1 over 1 minus r. And then if r is greater than 1, there's no sum and it diverges. And then I start the test. Because then if I go mind blank or anything, I can always refer back to the notes I took and wrote down first. Yes? This one is the first one. Now, we did this a different way the other day, and it was great and stuff. I want to show you another way today to show you an alternate way of doing this. However you want to do it, you can do it. It's the same thing we're doing, but we're just going about it differently. So if I said to you, so given a sub 2 is equal to 2 and a sub 5 is equal to 6, what is r? So if we, first of all, and let me just say one more thing. It's geometric. So this one is geometric. So I just kind of draw myself a picture so I can get an idea. So 2, 3, 4, 5, correct? So this is so a sub 2 is 2, a sub 3, a sub 4, a sub 5 is 6. Now think about it like this, you guys. So we know if it's geometric, we're going to be multiplying by a common ratio, correct, everybody? So we could go through and do the system of equations like we did on the other day, or we could just think of it like this. So we're going to times by r and get this number, correct? Now we'll times that by r and we'll get this number, correct? Then we times by r and we get this number. So isn't it a true statement to say 2 times r times r times r, r times r times r equals 6? So that's 2r cubed equals 6. So for r, divide by 2. So we have 3. R cubed is equal to 3. Cube root both sides of the equation, and we get a decimal, and that's totally fine. R equals whatever that decimal is. 1.4. Every decimal. Yes, every decimal. So we should write 4. 224,957. That's our R. Yep. Good question. Okay, next one. Everybody just watch. These are just quick. If I said to you, because a lot of you will tackle this the wrong way and you will spend too much time on these problems if we don't watch. So it says find the 6th term of this. Now notice it's to the 14th degree, correct? 14th degree. That's huge. If we wanted to use Pascal's triangle, we're going to be writing out Pascal's triangle for half the test. So think about it. 6th term of this. So I do like to write out a little bit. So 1, 2, 3, 4, 5, 6. The 6th term. Okay, awesome. Now it's degree 14. So to find the coefficients, let's use the binomial theorem instead of Pascal's triangle. This will be 14 choose 0, 14 choose 1, 14 choose 2, 14 choose 3, 14 choose 4, and this is 14 choose 5, correct? Okay, let's calculate 14 choose 5. So that would be, so NCR's formula is n factorial divided by n minus r factorial times r factorial. So we'll have 14 factorial divided by, what's 14 minus 5? 9 factorial times 5 factorial. Now let's simplify this smartly. That's 14 times 13 times 12 times 11 times 10 times 9 factorial. I stopped at 9 factorial so I can divide it out with my 9 factorial on bottom. 5 factorial is 5 times 4 times 3 times 2 times 1. So now I'm simplifying. 9 factorials divide out. 4 and 12 become 3 and 1, correct? 3 and 3 divide out. 14 and 2, right? 7 and 1, and then 5 and 10 become 2 and 5. Now multiply what's left over. 7 times 13, everybody type it in. 7 times 13 times 11 times 2. 2002. So now we're not done. That was the coefficient. If on Pascal's triangle we would have got all the way down, we would have found that, if that makes sense. So now we've got to keep going because we want the entire term. So our front thing is 3x. Now remember, your front thing will count down. No, yeah, count down. So this will be 3x to the 14th, 13th, 12, 11, 10, 9. So we're also going to have a 3x to the 9th here. And then our back term is 2y. It counts up, so 2y's to the 0. 1, 2, 3, 4, 5. So we'll also have 2y to the 5th. So now simplify that. Let's reorder that. That's 2002 times 3 to the 9th times 2 to the 5th times x to the 9th, y to the 5th. And now you'll actually type that into your calculator, that piece. Good question. Good question. I just got asked a really good question, and I was actually going to bring this up. So I'm not going to take away your calculator. However, if you don't show every ounce of work, you get 0 points. Like, I'm going to be very, very picky on that. Yes, good question. So I'm not going to take away your calculator. So see how the work I'm showing? That's what I would expect, roughly. Yeah, so it's a huge thing here. 1, 2, 6, 0, 3, 4, 1, 8, 5, 6, x to the 9th, y to the 5th would be our final answer. Okay. Question. Oh, dang it. Somebody got it wrong. That's okay. Okay, it's okay. It's easy to make a typo. Anyways, we get the picture. Let's move on. Okay, looking at this one. Notice, I would not want to do NCR for this one. I wouldn't want to do the choose because it's asking us to find this expanded completely. So I'm going to want all the coefficients. I don't want to have to do the choose thing. So use Pascal's triangle. 1, 1, 1. You have to be able to write out Pascal's triangle. We put ones on our diagonals, add straight down. 1, 3, 3, 1. Let's see how many degrees that is. 0, 1, 2, 3. Okay, so those are our coefficients, everybody. 1, 3, 3, 1. Let's continue this. Our front thing is 2i, right? So starting with 3, 2i to the 3rd, 2i squared, 2i to the 1st, and 2i to the 0. So I don't write it. My back thing is negative 3x. So this is negative 3x to the 0, negative 3x to the 1st, negative 3x squared, and negative 3x cubed. And now you'll simplify it correctly. 2 to the 3rd is 8. 8 times 1 is 8. I to the 3rd, guys, I to the 3rd is I squared times I. Why did I do that? Because anytime I have I other than if I have I higher than I to the 1st or I to the 2nd, we can always rewrite it in terms of I squared and I. Yep, so this is really negative 8i, correct? Okay, moving on to this piece. Don't mess it up. 2 to the 2nd power is 4. 4 times 3 is 12. 12 times negative 3 is negative 36, and we have I squared. So that's going to be plus, plus and x, correct? So plus 36x. Can't combine those two. Let's move on. So we have 2 times 3, which is 6, and then 6 times 9, correct? Positive 9. So 54 ix squared. Nothing more we can do there. So plus 54 ix squared. And then negative 3 to the 3rd is negative 27, and x to the 3rd. Notice we can't combine any like terms. There are some that you can, there are some that you can't. Does that make sense, everybody? If you did your math correctly, you're good. Okay, next one. Okay, if I gave you this, I'm not going to say to you, this is geometric, this is arithmetic. And I saw some of you accidentally start doing the wrong formula. Still get it wrong. So everybody look at this. Is this finite or infinite? Finite, 1 to 3. 1 to 300. Is it arithmetic? Yes. Okay, so we've got to use the sum for arithmetic. That's n over 2 times a sub 1 plus a sub n. Okay, let's calculate this sum. We're summing up how many terms? 300 minus 1 is 299 plus 1 is. So we're summing up the first through 300th term. So the sum of 300 terms equals 300 over 2. And then our first term, that a sub 1 just means the first term. Plug in your lower limit. 4 times 1 is 4 plus 1 is 5. Does everybody see how I got that? Plug in 300. 4 times 300. 1200 plus 1 is 1201. Now calculate that sum. You type it in. Everybody good with that? Right. Because yes. Good one. Yes? 180,900.
Why do you check 1
because that doesn't account for the first term that you're plugging in. So 1 to 300 is 300 terms. Does that make sense? So if this was 2, then you're plugging in 2 as well, I should say. If this started at 2, so you've got to account for 2. If you did 300 minus 2, you would be accounting for 2 that's also included. Does that make sense? Can anyone say that better than me? You're still there. Yes, you're still using the 1. Because if this wasn't a 1, it wouldn't be so obvious. Let's say this was 3. Then how many terms are we summing up? 300 minus 3. But that's not including 3. So then add 1 more. So 298. Good question. Okay, looking at this one, is it finite? Yes. So we got to use, is it arithmetic or geometric? Geometric, so you say to yourself, it's a finite geometric, that's this formula. A sub 1, 1 minus r, wait, right? 1 minus r to the n divided by 1 minus r? Yep, okay, summing up how many terms? 1 to 40 is 40 terms. So we're summing up 40 terms, which is equal to, a sub 1 means the first term you're actually putting in. Plug in 1. Don't just always say it's 4, because you got to plug in the lower limit. So 3 to the 0 is 1, so yes, a sub 1 is 4 in this one. Our r is 3, so 1 minus 3 to the 40th, all over 1 minus 3. So the sum of those 40 terms is whatever it is, okay? I'll just take your calculator and use that. Are you done? Okay.
Yeah, it's like,
Okay, so that's something we might see. That's something we might see. So I'm going to like this. Okay, so this is, everybody watch, 2.4315. I'd write down the entire decimal, and then we have our e to the 19th. So you would write that on the test, but then you would also say, so that's really, move the decimal 1, 2, 3, 4, 5, 7, 8, 9, 10, 11, that huge number. Yes. Yes. It'll be reasonable. Okay, yeah, it'll be reasonable, I promise. That one I made up on the top of my head. Which that one wasn't that unreasonable. That's pretty nice. Okay. Look at these ones. Everybody, please pay attention. I'm trying to help you. Is this finite or infinite? Okay, it's infinite. Is it geometric or arithmetic? It's geometric. Okay, so we can find the sum of certain geometrics as long as your r value is less than 1. Is it less than 1? So we can find the sum, a sub 1 over 1 minus r. This one's easy. The sum is a sub 1, plug in 0 into x. So 3 is our a sub 1 in this one again. And then 1 minus 4, 6. Everybody sum that up. Go, go, go. Use parentheses if you're going to type that in. Okay, so as we sum up more and more terms, we're getting closer and closer to 9 until we say, okay, the sum is 9. We're basically adding 0 once we hit 9. Okay. Now, next one, it's infinite. Is it arithmetic or geometric? Is the absolute value of your r less than 1? So no sum, it diverges. And then I probably just should have said converges to 9. Converges to 9. All right, it's infinite. It's arithmetic. Can we find a sum? No sum, correct? Arithmetic, infinite, can't find a sum. 0 to infinity, it's infinite. Can I find the sum of this one? No, it tricks people because they see a fraction, but that's a fraction larger than 1. 1.5 is greater than 1, so we can't find the sum. It diverges. Good, diverges. Okay, that's it.